You can still smell it if you try hard enough. That specific, almost biological combination of castor oil and methanol, not quite gasoline, not quite anything you've ever smelled anywhere else that used to mean Saturday morning, used to mean the field at the edge of town, used to mean something about to happen. The moment that engine fires, the moment that glow plug ignites the fuel and the propeller blurs into a silver disc, something changes in your chest, something tightens and releases at the same time. That's a K&B 40 Torpedo at full throttle. Nothing else sounds quite like it. Not a car engine, not a chainsaw, not a lawnmower, not any of the sounds the modern world makes. It's sharper than all of those, more focused, more urgent. At peak RPM, somewhere between 20,000 and 25,000 revolutions per minute on race fuel, it crosses the threshold from sound into something you feel in your teeth. The aluminum airframe of the plane vibrates in your hands. The smell intensifies. The world contracts down to this one thing. This 6.54 cubic centimeters of precision-machined Southern California engineering screaming its lungs out in the palm of your hand. John Broadbeck built his first engine in a garage in Los Angeles in 1944. Lud Kading worked the lathe. They had 2 old Logan lathes, some drill presses, and a shared obsession growing since they'd started flying models together in 1936. Before they could make their first model engine, they machined cannon yokes for Lockheed Aircraft and precision parts for the Manhattan Project. The same tolerances that helped build the first atomic bomb went into the first torpedo engine. That is not a metaphor. That is what happened. What Broadbeck and Kading built was not just a product line. It was a standard. A proof that small batch American precision manufacturing could produce something that mattered, something that kids would carry home from hobby shops in brown paper bags and old men would keep in wooden display cases, and competitors would run at speed on lakes and race strips from California to Florida to the shores of every pond in the country where someone decided to see what the machine could do. K&B Manufacturing outlasted almost every American model engine company. It survived the Japanese and Taiwanese imports, survived the death of the corner hobby shop, survived the video game revolution and the liability lawyers and the slow withdrawal of unsupervised outdoor childhood from American life. And in the end, after all of that, it survived in a form you could still order parts from, though what K&B became was a ghost version of what it had been. This is the story of what it was, and what it means that something like it may never exist again. Part 1. Southern California's Hidden Workshop Belt. The aerospace industry transformed Southern California in ways that most history books don't fully capture. Everyone knows about Lockheed in Burbank, Douglas in Santa Monica, North American Aviation in Inglewood. Everyone knows the airplane plants, the aircraft factories, the vast complexes where B-17S and P-51S and later jet aircraft were assembled by the tens of thousands. But what those histories leave out is the ecosystem, the web of smaller shops, the machine tool suppliers, the precision parts makers, the one- and two-man operations working out of converted garages and light industrial spaces scattered across. The model engine industry of post-war Southern California was not a cottage industry. It was a precision manufacturing sector built by aerospace veterans who happened to love a hobby. The companies that mattered in American model engines in the 1940s, 1950s, and 1960s were almost without exception based in Southern California. Olson and Rice, McCoy, Cox, K&B, and the VECO line that K&B would produce. This was the direct result of the specific industrial culture that the aerospace boom had created, a region full of skilled machinists, precision tooling, and men who understood that small was not the same as crude. The hobby shop in this ecosystem was not just a retail store. It was a junction point where the manufacturing culture and the hobbyist culture met. A shop like Hearn's Hobbies in Los Angeles or the scattered independent shops throughout the San Fernando Valley, was where a machinist who'd been making precision parts for Douglas aircraft all week could buy a set of model plans on Saturday, and where a kid whose father worked at Lockheed could watch that machinist tune an engine and learn something about patience and performance that no school curriculum taught. The climate mattered too. Southern California was a place where you could fly model aircraft outdoors in January, where local flying clubs had access to the dry lake beds in the Mojave and the parks and open fields that had not yet been absorbed by suburban development. The geography and the industrial culture combined to produce something that could not have happened quite the same way anywhere else in the country. John Broadbeck understood this world from the inside. He was not just a machinist who happened to build model engines. He was a modeler who happened to have machinist skills precise enough to turn his obsession into a product. K&B engines felt different from the products of purely commercial manufacturers because they were designed by someone who would run them himself, who knew what it felt like when an engine was right. The smell of that California workshop in July 1944, aluminum shavings on the concrete floor, cutting oil sharp in the nose, the high whine of the Logan lathes at speed, and underneath all of it, the ghost scent of methanol that any modeler of the era carried into every room he walked into. Two men with old machines and new dreams, making cannon yokes for Lockheed to pay the rent while they figured out how to make the smallest, most precise, most powerful model engine their hands could produce. Part 2. Built to a standard the world forgot. John Broadbeck was born in 1913. By the time he started K&B with Ludd Kading in July 1944, he had already spent years tinkering with the model engines available. The early Torpedo and Bullet designs machined in small shops around California and finding them wanting. The sleeves were too loose. Fuel would slip past the sleeve and out the exhaust, wasting power, producing a machine that was less than what its design suggested. Broadbeck didn't complain. He made his own sleeves, his own connecting rods, and he started thinking about what a properly made small engine would look like if the person making it actually cared about every dimension. The standard they set from the beginning was the standard of aerospace manufacturing applied to something the size of your fist. The same tooling, the same measurement practices, the same intolerance for variation that had been drilled into every machinist working for the Southern California defense industry. Broadbeck applied all of it to a cylinder bore of less than half an inch in diameter. Tighter tolerances meant better compression. Better compression meant more power from the same fuel. More power meant faster planes, faster boats, faster cars, which meant K&B engines won races. And winning races in the model hobby community of the 1950s was the fastest possible path to becoming the engine that every serious competitor wanted. The infant Torpedo, their 20 cubic inch engine, was the first proof of the standard. After 6 months of failing to build a working 10 cubic inch engine, Broadbeck designed the capsule plug, a one-piece combustion chamber and glow plug combined, which finally solved the ignition problem at extreme miniaturization. They doubled the displacement to 20 cubic inches. 1 week after introducing the infant Torpedo, they had orders for 280,000 engines because the modelers of 1,946 and 1,947 recognized immediately that something had changed, that here was an engine made to a different standard than anything they'd seen before. Ludd Kading left the company in 1953 to pursue other interests. The friendship endured. John Broadbeck never saw any reason to change the name, and the K stayed in K&B for the rest of the company's life. By 1961, they had settled in Downey, California, a blue-collar aerospace suburb where the production lines at North American Aviation in Rockwell built everything from B-25 bombers to the Apollo command module. The neighborhood was populated by machinists, engineers, and people who understood that precision was not optional. In the early 1960s, A K&B employee named Bill Wisniewski began designing what would become one of the most influential series of model engines ever produced in the United States, the Torpedo 29, 35, and 40. These engines shared design DNA with the old McCoy speed engines, a two-piece aluminum crankcase, rear or front intake, side exhaust, aluminum cooling fins, and a ball-bearing supported crankshaft. But Wisniewski's version was better in every dimension: a steel sleeve, a Dykes-ringed aluminum piston, a machined bar stock head. Engineering decisions made by someone who wanted to know what was possible. The 40 Torpedo became something close to the definition of an American model aircraft engine. In the Formula One pylon racing circuit, those low-wing racers circling pylons at speeds approaching 200 miles per hour, the K&B 40 was the engine to beat. Not because it was the only option, because it was the best option, consistently, race after race. At the same time, K&B worked with an outside designer named Clarence Lee, who had developed a 61 cubic inch engine, the VECO 61, that K&B agreed to produce in their Downey factory. The engine started as a 45, but the pattern competition planes of the era demanded more power, and it grew. By 1969, the VECO 61 was the engine of choice for serious radio control pattern competition. Its only real competition was the Webra Blackhead, which was expensive and hard to find. The VECO 61 was available, it worked, and it won. John Broadbeck was inducted into the Academy of Model Aeronautics Hall of Fame in 1977 and into the North American Model Boating Association International Hall of Fame in 1982. These are not honorary distinctions. They are the recognition of a technically serious community that understood what had been achieved, what the engines from the Downey factory had made possible in their sport, and their pursuit of what a small machine could do at full throttle. Part 3. The machines that made mechanics. You have to understand the ritual before you can understand what K&B meant to the people who ran these engines. It was never just about the machine. It was about the process of making the machine work, which was itself a kind of education that didn't exist anywhere else. Start with the fuel. The standard nitromethane fuel of the era was a mixture of methanol, nitromethane, and castor oil. The castor oil as lubricant, the methanol as primary fuel, the nitromethane as the power booster. A low nitro mix might be 10%. Competition fuel might run 50% or higher. The smell of this mixture, sweet and sharp and slightly medicinal, with the organic warmth of castor oil underneath permeated clothing, got into the pores of your hands, lingered in the fibers of anything it touched. Modelers of the era describe the smell of model fuel the way wine critics describe terroir. Not because they're being poetic, because the memory is that specific. Then the glow plug. Unlike a spark plug, it had no electrical connection during operation. A battery heated the coil to ignition temperature. The engine was started, and the battery was disconnected. The plug continued to glow through the combustion cycle, sustained by the heat of the burning fuel. The art of the glow plug was understanding when it was right, when the heat of the plug and the heat of the fuel were in the relationship that produced smooth, powerful combustion, rather than the lean-run detonation that would destroy a sleeve or a piston. This was knowledge that couldn't be read in a manual. It had to be felt. The needle valve was where the real tuning happened. Too rich, and the engine ran rough, produced less power, left unburned fuel in the exhaust. Too lean, and the engine made a higher, harder sound that sounded like power, but was actually the precursor to catastrophic failure. A lean run could destroy an engine in seconds. The art of the needle valve was turning it in tiny increments, a quarter turn, an eighth turn, listening to the sound change, feeling the vibration change in the model's airframe, interpreting all of this as data and responding in real time. This was not casual. This was a skill. The K&B 40 at full song was unmistakable. K&B veterans describe the way you could tell a well-tuned 40 from 300 feet away, a particular quality of the exhaust note, a sharpness at the top of the power band, a texture that the imports never quite replicated. The sound was information. The boats deserve their own chapter. K&B produced marine engines' inboard configurations, sealed against water ingress, optimized for the specific demands of hydroplane racing that dominated the NAMBA circuit for years. The 7.5 cubic centimeter inboard and the 3.5 cc car engine were built to the same standard as the aircraft engines, but adapted to an environment where the engine lived submerged in the hull, cooled by the water it ran through, connected to a prop shaft transmitting power at RPM levels that would destroy lesser engineering. Model boat racing at the high end was not gentle. These machines ran on the edge of what their materials could sustain, race after race, because the tolerances were right. The clubs that grew around K&B engines were the connective tissue of a culture. The Academy of Model Aeronautics provided the organizational infrastructure, but the actual community was built at the local level. The Saturday morning sessions at the flying field where older modelers helped younger ones understand what they were hearing when an engine ran wrong. The garage workshops where someone who'd been running K&B engines for 20 years would diagnose a newcomer's problem in 30 seconds because they'd seen it 100 times before. The hobby shop was the physical space where this culture lived during the week, the place where you could bring a sick engine and find someone who knew what was wrong with it, where the counter guy had opinions about fuel mixture that you were wise to listen to. Part 4. Saturday mornings at the lake. Picture it as specifically as possible. It's a Saturday morning in the summer of 1972, somewhere in the San Fernando Valley, the light already doing that sharp-edged golden thing that Southern California light does at 7 a.m. The park has a pond the city maintains for stormwater, which the local NAMBA chapter uses for boat racing on weekends when the parks department looks the other way. Maybe 30 people. A few are serious competitors. Most are there to run their boats and watch and talk, which is itself a kind of participation. The serious boats are hydroplanes, their hulls barely touching the water at speed, the K&B engine tucked into the hull behind a splash guard, the prop churning at speeds that would shred a less precisely made component. The less serious boats are runabouts built from hobby shop kits over a winter at the kitchen table, running long ovals while their owners manage the throttle with a radio controller and try to keep the needle valve in the right place. What's happening here is a kind of informal school. The 12-year-old kid who came with his older brother is watching the man 3 spots down the bank tune his engine, paying the kind of attention that school almost never induces. This scene played out in thousands of variations across the United States in the 1960s and 1970s. The AMA had more than 150,000 members at the hobby's peak. There were several thousand independent hobby shops in America, not chain stores, not big box retail, but shops owned and operated by someone who knew the product, knew the customers, and could serve both with the knowledge that comes from spending a life in a field. The hobby had its own publications, Model Airplane News, R.C. Modeler, Flying Models, its own competitive circuits, its own hierarchy of expertise. The national competitions, the AMA Nationals, the NAMBA Nationals were the high holy days of this culture. Pylon racing brought screaming K&B, 40 and 45 powered aircraft around triangular courses marked by 30-foot pylons, speeds approaching 200 miles per hour on the straightaways. The competition was technical in ways that outsiders found incomprehensible. The engine tune for the hot desert air at the Nationals in Tucson was different from the tune for the humid air at a regional contest in the Midwest. And that difference could be the difference between winning and losing. The mentorship culture was the part hardest to quantify but easiest to remember. Every serious hobbyist of that generation can tell you who taught them to tune an engine, who taught them to read a glow plug, who first showed them the difference between the sound of an engine about to destroy itself and an engine that was just slightly too rich. These were technical transmissions from one generation to the next, and they happened in the informal spaces of the hobby on the flight line, in the pit area, at the hobby shop counter. They happened because explaining something you love is one of the great pleasures available to human beings. The K&B engine was the right object for this transfer, precise enough to demand respect, complicated enough to require learning, but ultimately understandable to anyone willing to pay attention. You could take one apart and put it back together. You could feel the machining, feel the sleeve fit, feel the crankshaft spin in its ball bearings, and understand why it was good. Engineering made tactile. Engineering made accessible. These stories survive only because people choose to remember them. If this history matters to you, if the smell of methanol and castor oil still lives somewhere in your memory, or if you've never touched a model engine and you can feel in this story the outline of something you didn't know you'd missed, then subscribe to this channel and leave a like. Every subscriber is a vote to keep these histories alive before the last people who lived them are gone. This channel exists to tell the stories that the glossy histories leave out, the stories of the machinists and the hobbyists and the men and women who built the small but essential things that hold a culture together. Subscribe. It matters more than you know. Part 5. When the world stopped listening. The forces that dismantled K&B and the culture it represented did not arrive all at once. They came slowly, from several directions simultaneously. Each one manageable alone, devastating in combination. To understand what happened to K&B is to understand what happened to a specific kind of American outdoor mechanical culture in the last quarter of the 20th century. How it was eroded not by a single event but by the slow accumulation of small changes that each seemed, in isolation, reasonable. The first force was the simplest and the most powerful, the video game. Not one game. Not one console, but the steady improvement of electronic entertainment through the 1980s that provided a new answer to the question of what young people did with their time. In 1972, the Atari Pong cabinet appeared in arcades. By 1977, the Atari 2600 was in living rooms. By 1985, the Nintendo Entertainment System had The third force was the broader shift in American childhood toward supervised, structured activity and away from the unsupervised outdoor time that had historically been the incubator for mechanical curiosity. The child who would have spent Saturday afternoon in 1968 tinkering with a model engine in the backyard was, by 1988, more likely to be in an organized sport, an enrichment class, or inside with a game console. The backyard workshop, the garage where things got taken apart and reassembled, the culture of hands-on mechanical experimentation, all of this was being squeezed out of American childhood at the exact moment that K&B needed a new generation of customers. The fourth force was import competition, beginning in the 1970s and intensifying through the 1980s. OS engines, Enya, and Webra had been building quality model engines since the post-war period, but they became serious American market competitors in the mid-1970s when their products combined Japanese manufacturing efficiency with genuine engineering quality. OS, in particular, produced engines that matched or exceeded K&B quality in specific categories, while offering broader availability and more competitive pricing. The Taiwanese manufacturers that followed captured the entry-level market that had historically been K&B's pipeline for future serious customers. By the mid-1980s, the premium that K&B had commanded on the basis of American precision manufacturing was under real pressure. The fifth force was the economics of precision American manufacturing. The cost of machining a model engine crankcase to K&B tolerances in Downey, California, was substantially higher than machining the same part in Osaka or Taipei. This gap had always existed. It was acceptable when K&B quality was demonstrably better. As import quality improved, the justification for the premium narrowed, and K&B's investment in CNC tooling in the mid-1980s, expensive, necessary, and made to serve a market that was contracting, could not reverse the mathematics. Part 6. The spreadsheet that killed the soul. The transition from John Broadbeck's K&B to what the company became in its later years was not a single dramatic moment. It was a series of decisions, each understandable from the perspective of whoever was making them, each incrementally moving the company away from the standard that had made it worth having. John Broadbeck's son, John Broadbeck Jr., eventually took over running the company. Jr. understood the business and the product, but the pressures he faced were different from his father's: a harder market, more sophisticated competition, and the constant problem of producing engines to K&B standards in Downey, California, at a price that could compete with Osaka and Taipei. The company was eventually sold to Randy and Anching Linsalato, whose enterprise RJL continued to market the K&B engine line. The challenge for any new owner of a precision manufacturing company built around a founder's standards is that those standards are only partly captured in specifications and procedures. The rest lives in the judgment of people who have been doing the work for years, in the institutional knowledge that walks out the door when experienced machinists leave. When ownership changes, that knowledge is at risk. The decisions that damaged K&B's reputation in its later years are documented in the hobby press and in forum discussions among collectors and restorers. There were quality consistency issues not across the board, but enough to plant doubt. There were carburetor problems in certain production runs. Reports of tolerances that were not quite what K&B tolerances had historically been. For an engine company, this is catastrophic in a specific way. The model hobby community was, and still is, intensely word of mouth. An engine that behaves badly at a Saturday morning contest is discussed. The production of the K&B engine line eventually moved from Downey to Arizona, a relocation that made economic sense, and in the process, separated the engines from the specific Southern California machining culture that had been the invisible ingredient in every engine off the Downey line. The workers who had grown up in aerospace shops, who had spent careers learning to listen to a machine the way a doctor listens to a patient, were not easily replaceable. The relocation cut the last physical thread connecting the K&B engine of the late period to the K&B engine that John Broadbeck and Bill Wisniewski had built in Downey. Eventually, production returned to Southern California to Monrovia under the VECO banner, but the continuity was by then more nominal than real. Part 7. The last engine off the line. The K&B name today belongs to Model Engine Corporation of America, MCOA, operating out of Sierra Madre, California. They still sell K&B engines and carry the full parts catalog. MCOA claims that 99% of all K&B parts are in stock, and the community of collectors and restorers confirms this is largely true. For an engine line out of continuous high-volume production for decades, that parts availability tells you something about how seriously the people who care about these engines take their responsibility to the machines they love. The collector and restoration community around K&B and VECO engines is small by the standards of automotive collecting or vintage watch restoration, but it is intense in the way that precision hobby communities always are. These are people who can date a K&B 40 by the style of the fins, by the carburetor thread pitch, by the color and finish of the castings. They know which production years had the best quality control and which had problems. They can feel, when they thread a K&B connecting rod into the crankcase, whether the machining is right, a judgment that only comes from handling hundreds of examples. On eBay and the model engine collector forums, K&B engines in good condition command real money. A K&B 40 Torpedo in running condition with the original box is not a $5 yard sale find. A VECO 61 inches competition configuration can bring hundreds of dollars. These are not record prices, but they tell you that the community values these objects as physical things that embody a specific quality and a specific history. What happened to the actual factory in Downey is the kind of history that doesn't get recorded. The buildings absorbed into industrial zones are the invisible monuments of American manufacturing culture. No plaques, no historic preservation. Someone works in a space where K&B engines were made without knowing it. Manufacturing history ends not with a ceremony, but with a change of tenant. John Broadbeck passed away on the 2nd of November, 2004, at 91 years old. Lud Kading, his partner from the garage in 1944, passed away on the 25th of February, 2011. Between them, they had built the longest continuously operating model engine manufacturer in American history, won every significant honor their industry offered, and created something that the people who remember it describe with a specificity and warmth that suggests the memory is not merely nostalgic. It's the memory of something that was genuinely good, genuinely well-made, genuinely worth caring about. Closing. What we lost when the engines went silent. There's a question at the center of this story without a clean answer. Was K&B killed? Or did the world it was built for simply disappear, leaving the company stranded in a landscape that no longer had use for what it offered? Both things are true. The world changed in ways that created the conditions for K&B's decline: the video games, the liability culture, the decline of unstructured outdoor childhood, the import competition. These were structural forces operating at the level of American culture, and they would have eroded the model engine hobby whether K&B was perfectly managed or incompetently managed. The hobby depended on something that American culture was systematically withdrawing: the free time and physical freedom that childhood used to come with as standard equipment. But the specific loss of K&B's standard, the erosion of the tolerance and the precision and the institutional knowledge that made Downey-built engines sound and feel different from anything that came after that, was not inevitable. That was a series of decisions. Here is what a K&B engine was, reduced to its essence: the product of the belief that small things deserve the same precision as large things, that a cylinder bore of less than half an inch in diameter deserves to be held to the same tolerances as an aircraft engine. John Broadbeck believed this not as a philosophy but as a reflex, a standard, through his years in the Southern California machine shops, that he couldn't have made a sloppy engine if he'd tried. What we lost when these engines went silent was not just a product, it was a demonstration of a principle: that precision could be democratized, that the engineering standards of the aerospace industry could be packaged in something a 12-year-old could buy at a hobby shop and tune at the kitchen table and run at the pond on Saturday morning. That manufacturing excellence and popular accessibility were not mutually exclusive. The children who learned mechanics through model engines became engineers, machinists, technicians, pilots. The patience required to tune a needle valve transferred to patients with other systems. The hobby was not frivolous. It was an education delivered through pleasure, which is the most efficient delivery mechanism for education that exists. What we have instead now is not nothing, but something specific was lost when the outdoor mechanical culture of the mid-20th century dissolved something about the physicality of the knowledge, the irreducibility of a real engine that will not run if you don't understand it. Pick up a K&B Torpedo 40 if you ever find one at an estate sale or a swap meet. Hold it in both hands. Feel the weight, just over half a pound, machined from aluminum and steel in Downey, California, by men who applied aerospace precision to a hobby. Turn the crankshaft with your finger. Feel the ball bearings, the smoothness of the rotation, the way the compression builds at the top of the stroke. This is what a thing made to a standard feels like. This is the difference between adequate and right. There are people who will keep these engines running as long as they live, and who will teach whoever will listen what the sound means. They are the last keepers of a specific knowledge. When they're gone, we will have the engines, but we will have lost the ability to hear what they're saying. Listen while you still can.